Today, we're diving into the technology that's literally giving smart factories their pulse, digital twins. This is how machines are learning to talk, and believe me, it is changing absolutely everything about how we make, monitor, and maintain things.
Okay, just picture this for a minute. What if that super critical pump on your factory floor could just send you a message? Something like, hey, my internal pressure is acting a little weird. You've got about 72 hours before I'm going to fail. This isn't some sci-fi movie plot. It's the exact problem that digital twins are solving today.
I know, a machine that tells you what it needs, it sounds like pure science fiction, but it is happening right now, and it's all powered by a combination of smart sensors and some incredibly powerful virtual models. So to really wrap our heads around how this all works, we're going to go on a little journey. We're going to follow the entire life of just one piece of equipment, a humble industrial pump. From its very first digital spark to its life on the factory floor, we're going to see how it gets a voice. So where does it all begin? Well, it starts long before any metal is ever cut. The first stage is what we call the digital birth, and let me tell you, it's so much more than just a simple blueprint. For decades, we've had CAD models, right? They're basically static 3D blueprints. They show you what a pump looks like. A digital twin, though, is a whole different animal. It's a living, dynamic, virtual replica. It doesn't just show you the pump's shape, it simulates its exact behavior under any condition you can dream of. And how on earth does it do that? Well, by gobbling up a massive amount of data. We're talking about its performance curves, how it's supposed to operate, the specific properties of all the materials it's made from, the operating conditions it's going to face, and, this is the really crucial part, a connection for live sensor feedback, which we'll get to in just a sec. So what this means is that before a single penny is spent on manufacturing, engineers can push this virtual pump to its absolute limits. I mean, they can simulate running it in the scorching desert heat or the freezing Arctic cold, finding every weak point and optimizing the design, all from the safety of a computer. Okay, so our pump is designed, it's built, and it's installed. Now the digital twin really comes alive, and this is all made possible by something called the IIoT. IIoT. It stands for the Industrial Internet of Things. Now, if that sounds complicated, don't worry. At its heart, it's really just a network of smart sensors and devices that are embedded right inside the industrial equipment. Their whole job is to constantly collect data, things like pressure, temperature, flow rate, vibration, and share it instantly over a network. Honestly, the absolute best way to think about IIoT is like a fitness tracker for your machinery. Like a Fitbit or an Apple Watch. It monitors all the vital signs in real time, giving you this constant, live-streamed health report for every single piece of your equipment. So what are these fitness trackers inside our pump? Well, they're smart components, things like cylinders that can report their exact position or tiny sensors measuring pressure and airflow. This data is the pump's pulse. It gets fed into a central system, like a manufacturing execution system that constantly updates the digital twin with exact what's happening in the real world right now. And now we get to the really powerful part. We have this perfect virtual model, and we're feeding it a live stream of data from the real world. This is where we stop just monitoring the present and start actually predicting the future. You see, because the digital twin knows exactly how the pump is supposed to be performing, it can spot the tiniest deviations from that ideal state. A slight increase in vibration, a minuscule drop in pressure, things a human would never, ever notice. The twin flags these little anomalies and can calculate that they're the early warning signs of a specific part failing soon. And that, right there, is the magic of predictive maintenance. And as you can imagine, the business impact here is just enormous. With predictive maintenance, you're talking about a dramatic drop in unplanned downtime. You can optimize performance for way better energy efficiency. It even makes regulatory compliance and tracking easier. But at the end of the day, it gives you the hard data you need for smarter, faster decisions across the entire board. So at this point, you might be thinking, okay, this all sounds amazing, but it also sounds incredibly expensive and complicated. Well, the good news is getting started is actually more accessible than you might think. The key is to not try and boil the ocean. You just start small. First, identify one really critical piece of equipment, the one machine you absolutely cannot afford to have go down. Second, retrofit it with some smart IIoT-enabled components. Third, just focus on collecting and analyzing the data from that one asset. Once you see the value and the return on that investment, that's when you can scale the project up. It's a really manageable step-by-step process. Ultimately, adopting this technology isn't just about solving today's problems, it's about positioning your entire operation to be competitive and resilient for the massive changes that are coming to the industry over the next decade. It's really about future-proofing your business. And that leaves us with one final big thought. We've just followed the story of one pump. But imagine a future where every single component in a factory has a voice, a digital twin, and is constantly sharing its story. What new efficiencies, what new products, what incredible new insights will our factories teach us then? It is a very, very exciting future to think about.